This video describes how to use the AOC platform to develop and deploy an SSP package. Network programmability plays an important role in the area of network automation due to the increasing cost of operating networks and the OPEX-CAPEX ratio that is too big for operators. Thus, operators must automate the network via programmatic configurations of the network, which require network-level service configurations over multiple network elements at the same time, rapid service rollout and rapid multi-vendor device adaptation with simulations, dry runs, and service verification, and simplified service interfaces that make use of standardized modeling languages, vendor-agnostic models and interfaces, and that simplify device models and focus instead on network-wide services and user intents. The AOC enables network automation via Young-powered openness and programmability, rapid multi-vendor integration, and high reliable network changes. The Young-powered openness and programmability is guaranteed through service and device models, mappings between the service models and the network device templates, and automatic generation from the Young models of northbound APIs and southbound APIs. Rapid multi-vendor integration supports the separation of multi-vendor integration layer from service models and logic, the import of vendor-specific Young models, the multi-vendor integration via Jinja 2 templates, and device Young models over netconf or CLI. AOC as well enables the simulation, dry run, and verification of the service models, and provides a comprehensive transaction mechanism and configuration rollbacks. AOC relies on service-specific plugins, SSP, packages that describe the service models to be deployed on the network. These SSPs comprise of service Young models, mappings between service models and device models via Python code or Jinja templates. As mentioned before, an SSP package contains a service Young template, Python code mapping, and southbound Jinja 2 templates. However, before developing an SSP package, we first need to prepare the environments, which include the AOC environment and the local development environment for the SSP package. In the AOC environment, network devices should be managed by netconf. For the local development environment, the following tools need to be installed: Python version 3.7, AOC API, pyoung, and Git. In this video, we use PyCharm as the development and local verification tool for the SSP package. In the AOC environment, the AOC Lite Edition and Huawei NE8000 devices are used. The design of the SSP package is an important phase. In this phase, we need to provide several parts for the SSP package, including configurations to be delivered to network elements, parameters to be carried in the service model, fixed parameters in the network element template, as well as the mapping logic to be implemented. In the example discussed in this video, we develop an SSP package to deliver a specified subinterface to a specified device and add the description for this subinterface. The subinterface is the service to be carried by the SSP package. Let's first look at the process of developing a subinterface SSP package. The process consists of several steps. 1. The first step is to prepare the XML configuration for the network element Young model of a subinterface. The second step is to create in AOC a sub-interface SSP template package, download the package to the local host, and use PyCharm to load the project in the local environment. The third step is to develop the Young model for the network service of the sub-interface in the local environment. The fourth step is to develop the mapping logic between the network service layer and the network element layer. The fifth step is to verify the SSP package locally. The final step is to pack the SSP package in the local environment, load it into AOC and verify it. If you are familiar with the Young model and configuration, you can perform dry run on the network element management page of AOC in order to obtain the corresponding NE configuration. If you are only familiar with the CLI operations of the device, you can perform configuration on the device and synchronize the configuration to the AOC. In this way, you can also obtain the corresponding NE configuration. In the network service Young model of the SSP package, only the device name, interface name, and interface description need to be provided in this example. This will be described later in the video. There is no parameter that needs to be fixed in the NE template. The mapping logic is simple and will be described later. Next, I will show you how to configure a sub-interface on a device and then synchronize the configuration to the AOC to obtain the NE configuration XML file. Log in to the device and configure a sub-interface. In the system view, configure sub-interface on Gigabit Ethernet and configure the device description Hello World. Then commit the configuration. In AOC, in the device configuration, select the device and initiate the synchronization operation. Wait until the synchronization is complete. Then select Edit, go to the editing page and view the synchronization result. Find Huawei-IFM and then Interfaces. Now we can see that Gigabit Ethernet has been synchronized and the interface description in the device description is Hello World. After the preceding operations, we need to create a template sub-interface SSP package in AOC through the packet management section. Once the attributes of the templates have been filled in, the template will be displayed in the list. This template will then be downloaded from AOC and imported in PyCharm in the local environment. In the AOC, choose Package Repo and then on the left-hand side, click Package Management. On the Package Management page, click Create Template. In the dialog box that is displayed, set the SSP package attributes and click OK. The newly created SSP package is displayed in the package list. The next step in the development of the SSP package is the development of the network service Young model. This Young file is in the Young folder of the project in PyCharm. This slide shows the network service Young model that we want to obtain for the sub-interface service. This model defines a sub-interface node which consists of 3 service-related parameters: device, IF name, and description. These parameters indicate the device name, interface name, and the description. IF name and description are combined into a key, as it can be seen on line 15. In the Young directory of the imported project in PyCharm, modify the subinterface.young file to resemble the example shown in the slide. Next, let's move on to the development of the logic for mapping from the network layer to the NE layer. The left part shows the service Young model, and the right part shows the NE Young template. Device, IF name and description in the service Young file corresponds to 3 expressions in the NCE Young template. The content enclosed in double curly braces is the result of the expressions to be filled in the template. Inventory-CFG is the root node of the AOC NCE Young template. NCEs and NE indicate the NE configuration corresponding to an NE node. The toNE-ID filter can find the corresponding device ID based on the device name. Let's look at the detailed procedure for the mapping in the local environment. Modify the servicepoint.j2 file in the directory to resemble the content on the right-hand side. After the editing of the SSP package is complete, we need to perform local verification. 2 methods are available. The first method is to directly verify the service young model that we have just edited using pyoung. The second method is to generate the network layer XML configuration of the service young model using pyoung, use the XML configuration as the input of a test case, execute the test case, and finally check whether the output complies with our expectation. If the output meets our expectation, we can then pack the project, upload it to the AOC environment, and deliver and verify the configuration in the environment. Let's look at the detailed procedure for performing local verification. In the local environment in PyCharm, in the directory test/subinterface, update the Python file. Update the XML variable to make use of the subinterface parameters. Set device to testa, ifname to ifname1, and description to hello world. Then execute the test case and check the test result. The test result shows that the verification meets our expected output. Finally, we pack the SSP package developed in the local environment and upload it to the AOC environment. In the package management page, select the import button and then select the packed SSP package. Once the package has been imported into AOC, a new entry in the list is shown and the operational status of the package changes to deployed. Then we activate the package from the operation column, and after a few minutes the package status will change to active. The final step is to create a service instance, configure it, execute a dry run on it, and verify its configuration. Click Service Management, and on the left pane select Subinterface as the service type, then click Add. Select your service from the list and click Dry Run from the top menu. Verify the dry run result, and if the result is satisfactory, click Commit Configuration. After the configuration is committed, log into the device and check whether the configuration is correctly delivered to the device. Now we can see that Gigabit Ethernet has been correctly delivered to the device. This is the introduction to the development and verification of an SSP package. Thank you.